Alrighty, back to it, folks. Let's get to circles for a minute, kind of like when Saturn, back old jokes, right? Okay, so circles are pretty straightforward, pretty simple, okay? The equation of a circle is based on the distance formula, right? A circle is a fixed distance from a center at all times, right? Going all the way around. So basically you're saying the hypotenuse stays the same. So this looks remarkably like the way we remember the Pythagorean theorem, right? A squared plus b squared equals c squared. It's just different letters. X and y for our x and y coordinate plane, r for the radius. So for a circle centered at the origin, it's in this form where the radius is squared here. So to get back to the radius, we have to square root that number. So what's the square root of 4? Yeah, you got it. It's 2. 4 is the same as 2 squared. So we have a circle centered at the origin with a radius of 2. So I'm going to mark it by putting little marks 2 units out, and then I'm going to draw my terrible circle like that. Okay, so I've got my circle-ish that has a radius of 2. Now, of course, we want to translate that circle and be able to move it to other places around the coordinate plane. And the way we do that is with center form centered at h and k. And if you recall back from Algebra 2, I kept pointing out that we're going to keep seeing this idea of subtracting h and subtracting k to find where a center would be. Well, the same idea is going on here. So the form is x minus h squared plus y minus k squared is still equal to the radius squared. So in this example, x minus h is the 1. So notice, it's not negative 1, what we're looking at, it's positive 1. Okay? So our center is at 1 comma. Now this is y plus 2. We would think of that as y minus a negative 2. So y minus k is negative 2, the opposite of what we're seeing here. Negative 2. And then we could see here the radius. Well, what's the square root of 9? Just like the square root of 4 was 2, the square root of 9 is, 3. So now we're going to have a circle centered at 1 comma negative 2, right about there, with a radius of 3. So I'm going to go up 1, 2, 3, over 1, 2, 3, 1, 2, 3, 1, 2, up. I got to go a little further down. And then here comes another Easter egg from you. And there's our circle translated. 1 unit to the right and 2 units down. So if you know where the center is, you plug it in for h and k, and if you know what the radius is, then either using the distance formula or being able to count up or down an axis, or side to side on an axis, then you can get your radius there. So there's the beginnings of that stuff for you, folks. And again, this is all coming around to this idea of linear programming, which we're going to do next class. I'll see you in a few. I got one more video after that, and that's where I'm going to give you your popsicle joke. So I'll see you then. Bye.